Hello, greetings. In this brief tutorial, we will learn how to forecast and balance cash flows within the project. And we will do so by looking at a case study of an excavation project. So you can think of it as a large excavation project with a number of different zones indicated by different numbers over here, right? So let's switch on the pen option. And the first thing we will do is we will have to study what are the key activities, what is their logical order, and based on this, we will draw this logic diagram, or it's also called an activity on a node diagram, which essentially tells us about the precedence relationship. So basically you can see, for instance, between activity and K and W, there is a finish to start relationship. So this basically tells us that activity K would only begin once activity W has finished. And likewise, we do as a first step the forward pass, which helps us calculate the early start time and the early finish time for different activities, and then the backward pass, which helps us calculate the late finish and the late start time. And then we use this information to calculate slack or float, which is usually done by taking away the value on the top from the value at the bottom. So we take away late start time from late finish. So 17 take away 15 is 2, which is the slack in this particular case. Likewise, we have calculated slack for all these activities. Once we have done this, it gives us an idea about the critical path, because all activities with a zero slack are critical activities. These are the activities which could not be delayed. Delaying any of these activities would delay our overall project. So you can see that these activities comprise the critical path. So as a project manager, you should be very concerned to ensure that these critical activities get delivered on time. Right, so moving on, we can see on the table at the right, we have got the budgetary allocation. So the activity W has a total budgetary allocation of $45,000, and as it's a 2 months duration, the monthly breakdown would be 45,000 divided by 2, which is 22,500. Likewise, you can see the monthly budgetary provisions for each of the activities. So we use this information to draw a bar chart. So we see the very first activity in our project is W, and the early start is 0 and the early finish is 2. So basically tells us that this activity is starting at month 0 and finishing by month 2, and the total budgetary allocation is 22.5 per month. Once work on W has finished, we can work on 3 activities simultaneously, K, B, and P. And with K, you can see there is a healthy float of 3, which is indicated by this line over here, whereas activity B is a critical activity with no float, and activity P has got an enormous float of 8 weeks, indicated by this line over here. Right, so this particular problem has got a particular constraint, and that constraint is that the owners have can guarantee to finance the project only to this limit. So the owners have told you cannot have any more than $110,000 money. So if you take in perspective this constraint, you can see that there is a bit of a problem coming here, because in certain months your monthly budgetary requirements are much more than that. So we calculate the monthly budgetary requirements by taking a summation of all the values on the top. So you can see month 4, 5, and 6 have got budgetary requirements of more than 110,000. So issue is, how do we go about resolving this issue? So the best thing to do is to identify, so we have to address this issue of cost overload. So the first thing is to explore where are the floats and how could we use the float of different activities to adjust this cost overload. So we'll start by looking at the activities which are taking place in this region, and we can see that in this cost overload region there are these activities which could be affected. So K, B, P, and F. Now of these, you can see that activity B is a critical activity. It doesn't have any float, so we cannot do much about with this activity. So question here is, will using the float of activity K help in this particular situation? So one possibility is that we delay the start of activity K and move it to either week 4 or month 4, 5 or 6. But that's not going to help us because that's going to increase the cost overload further. So there is no point in delaying the start of activity K, because if you take it to week 5, for instance, and if you do work which is a 1 month work, and if you do it in month 5, you would see that the cost would rise from 132 to 144. That's not going to be of much help. So no, the answer is we cannot do much with activity K, so we move on. The second question is, will delaying activity P be of any use? So there is a possibility of delaying the work. So we take this block of work and use it at some other point. So I think there is a bit of an issue of delaying it and doing it in month 7, because if you put a 36 here, that is going to take you again in the red zone. So that's not what you like to do. So we would not like to do it in month 7. But here you can see a big trough in terms of cost requirements starting on month 8. So I think it would make a lot of sense to postpone it. So if we do it like this, so we could have 36, 36, 36 and 36. So what it would do is it would lower the cost requirements during this period, and we would be able to get rid of this cost overload zone, and perhaps it would result in a curve like this, because the cost requirements would increase. So this is one possibility. We could possibly relocate P from month 8 to start slightly later. And still, if we started at month 8, we would be left with quite a healthy float of 3 months over here. However, the problem with that may be that delaying activity P may take away the float for the activities F and O. So your activity F, it will eat up some of its float, and likewise for activity O, it would eat up. So if you are doing it on a computer, it would be much more easier to see. Anyhow, that is one possibility to delay this activity. Another possibility is to instead of delaying activity F, you could possibly delay activity F. So you can take away this 48. It would not be wise to delay it here, because it would put too much of a resource load. But we can see there's a big trough here, and possibly activity F could be delayed, and this would have a minimal impact on the subsequent activities and the issue of. So I think that looks like a logical case to postpone activity F slightly. So here you can see the readjusted situation. So we have essentially delayed 2 activities. So activity F has been delayed, and it is now taking place in this sequence, and activity O has a precedence relationship with activity F. So activity O can only happen once F has taken place according to the logical order. So activity F is now taking place here. So this way we have seen that we have got a very smooth resource profile, which is according to the contractually agreed maximum level of funding. So what we learned from this example is that float gives management team the ability to manage different types of resources. From resource management viewpoint, float is sometimes more important than the critical activities, because you cannot do anything with the critical activities, whereas the activities with float can be adjusted, and this gives you some room to play with. And with critical activities, management has no choice. Float gives manager ability to fine-tune the project and better manage cash flow and other resources. Thank you very much, and look forward to speak to you again.